A pixel is the smallest unit of programmable color on a display. Pixel is typically made up of red, green, and blue color components. When manipulating the intensity of each RGB value, the pixel emits a color you see. Pixel doesn't tell you anything until you start looking at the physical properties of the display, screen size, resolution, and dots per inch. A screen size is diagonal measurement of a screen from one corner to another. Resolution is the number of pixels in the display, which is most typically expressed as the number of pixels along with the width and height of the device. Screen size and resolution can be used to calculate the pixel density, pixel per inch (ppi). Dots per inch (dpi) is a holdover term for the printing world, where a dot of color is printed on the page. PPI and DPI are often used interchangeably, even though that's not exactly the same. PPI gives you a measure of image sharpness. Means if you see something very clear, means it has good PPI. This table gives you the comparison between the monitor and the iPhone with PPI. So the size is 617 and the resolution, you can see PPI is 34, but on the iPhone 35-inch you get a 163 with the resolution, same resolution, but you can see they look kind of different. The iPhone gives you sharpness image. iPhone introduced the logical concept of a point. A point is the unit of distance that can be scaled independently of device resolution. An LS point is 1 out of 163 of an inch. When defining style in native React, we use the logical concept of pixel, point on iOS and DP on Android. This picture shows you the difference between different devices. Like original iPhone, 1 point is 1 pixel, but on iPhone 4, 5, 6, 7, 8, 1 point is 4 pixels, and 1 point is 9 pixels on iPhone 6, 7, 8, and X. Means the point become more. 1 point means more and more than the original one. 1 time, 2 times, 3 times more. We can create a drop shadow in iOS with a shadow prop type iOS. Shadow opacity create opacity. The 0 means no opacity. If you put a 1, that's the full opacity. So the range for this value is 0 to 1. And we use a width and height to set or to move the shadow by X and Y direction. Shadow radius blurs the edge of a shadow. This picture gives you an idea about different shadows. So this is the one without a shadow. Now here you can see the shadow here. And this one you can see the with. In order to show shadow, you need to provide a shadow opacity and also provide X move this direction, Y moves down here. If you give a bigger value, you can see moves further to the right and down. And you can call radius to blur the shadow with different degree here. Because let's say you get a very light shadow here, and like this. You can also just provide a Y direction to move it down. That way you don't see any X direction here. Or you can give a negative value to move it up to the left. Now to make all of these, this table shows you how you can set the shadow color, and X, Y for the shadow offset, shadow opacity, and shadow radius to show the blur. And you cannot do exactly the same thing on Android. With Android, you control the Z order of the component. If two or more components occupy the same place, you decide which one should be on top or in the front by giving a larger elevation. Therefore, the larger Z-nex will create a small shadow, but it's not exactly the same as iOS. So there's a difference between iOS system and Android system. Sometimes you can make it on Android, doesn't mean you can see it on iOS. If it shows on iOS, doesn't mean that you can see it on Android, because they are different systems. This picture gives you the difference between iOS and Android when we work on the Z order. See, like iOS, we have A, B, C. C is on top. iOS ignores the style and always render box C on top of B and B on top of A. But on Android respects the style and flips the order in which it renders the boxes. And could be like this: A is on top. Flipped order, Android doesn't make any change, but iOS doesn't make any change, but Android will make change. So this the table give you an idea here. Originally we have this A, B, C, and then when we flip the order, then we change the 3 to 1. That's the elevation, and you don't see any change on iOS, but you see the change on Android. So that's the difference between Android and iOS.